gotten an email.
Okay. Okay, I'm just going into it right now. So, 1 second. Save. Save the code. Okay. So, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.58 and to the left of negative 1.358.
It's 358 for both of them.
Yeah.
358?
Yeah. Okay.
Just the number 358?
No. Just read it again, Matt. You read it wrong. Okay.
Are you trying to say 1.358? I'm just not hearing
Yeah.
you.
Yeah.
That's what I thought it was too.
You have read 58 before, and this is the 3.
Okay. Which of the following will have a smaller deviation?
Wait, hang on. We have to put the answer in.
Oh, I
1.
thought you guys had done that already. Sorry.
No, 0. Did you guys get 0.175?
Yes.
Okay. Now you can move on.
Yeah, that's what I got.
Okay.
I thought that's what you were saying the answer was 1.358. Okay.
No, you just read the problem wrong. That's all. Okay.
Okay. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of individual observations, the distribution of the sample means, and this cannot be determined from the information given.
I don't know. I don't remember doing a problem like that
I
before.
think it's the distribution of the individual observations.
You think so? Why?
Well, in one of the assignments, it was saying that with a smaller sample size, that there would be a smaller standard deviation.
They said, I think it was with a bigger sample size, there's a smaller standard deviation.
Oh, okay.
But we can try that anyway.
I kind of feel like you needed more information to solve this thing, but
Yeah. Well, it's mostly just deciding what the difference is between the individual observations and the sample means. So, okay, so what they're saying is if we have like 10 numbers or like 100 numbers that we looked at, each of those numbers, like the standard deviation between all of them, so what that is, versus if we have like 100 numbers and we take the mean of 10 and then we take the mean of another 10 and then the mean of another 10, which is going to be the highest standard deviation between the means of all those 10s or between all of the numbers as a whole. You know what I mean? So that's what they're asking us. So this one's kind of weird. Has Amber come yet? No. Okay.
I don't know.
You did start the recording, right?
Yeah, I did. So are we thinking C then, or are we wanting to go more towards the distribution of sample mean?
I don't know. I'm just gonna pick something because we could take the quiz again.
Okay, I'm gonna see. Which of the following results implies that the spread in X decreases as the sample size increases? Normal distribution, 68, 95, 99 rule, essential limit theorem, and the law of large numbers.
I think it's the law.
Yeah, this is the law of large numbers.
I
I
agree.
agree with that.
Okay. All right. Sources on the quantitative portion of the GRE are approximately normally distributed with the mean U equals 150.8 and the standard deviation 8.8 equals 1.
So,
Or
what
no,
do you think that little 1 after means? I don't know.
know.
Well,
I don't think we need to worry about it.
probably
Yeah.
not.
Okay, Diane earned a score of 160, so that would be the X, on the quantitative portion of the GRE. What is the Z-source corresponding to Diane's score?
Okay.
So
Let's see.
that would be the Z-score formula then, obviously, right?
Yeah, just make sure you use the correct formula.
There's two different ones that we were using.
Mm-hmm.
This one would just be Z equals the mean minus the standard deviation, right?
Yeah.
Sorry, just trying to gather my information. Okay.
Okay, what did you guys get for the Z-score?
I got 1.045.
Me too, because I don't think that they didn't say anything about a sample or sample means. So I don't think we have to use that. So what is the Z-score corresponding to Diane's score? I'm not used to just stopping with the Z-score.
Sorry,
Like I want to do more problems, with it.
I'm just trying to get my calculator. You said you got 1 point what?
0.45.
Okay, I got that too.
I got that too.
Okay.
The next question's that same number.
Okay. So
I think we have to use the probability applet.
That's what, but I just meant like we're gonna use the
Okay.
Z-score we found.
Okay.
so we'll just plug in that number then.
It's 0.148,
Yep,
right?
that's what I got too.
Okay.
Okay. Is everyone ready to move on to 8?
Yes.
Yeah.
A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the Z-score corresponding to the sample mean of these students' scores? Round your answer to 3 decimal places. So this one's a different equation, right?
Well, I think it's just we
need to find the mean first.
yeah.
Mean. Oh yeah, duh. Okay.
Okay, you guys tell me what you got. I got 160.
That's what I got.
Okay, so now that we have that, what is the Z-score? Oh, that's all we needed right now. What is the Z-score corresponding to the sample mean of these Z-scores? What is it?
Oh, I think this is the one where you have to divide by the square root of the
That's
sample.
what I'm thinking too.
Yeah, but we don't. Which number are we gonna subtract the mean from?
150.
Is that what? Is that? Where did you get that?
Oh, sorry, 158. 150.8.
Oh, because we're still using the information above.
Yeah.
Wait.
Wait, it's
No,
not 150.8,
it's not.
it's 160.
160 is the mean, but what I'm saying is what's our x? Because we just, hang on.
I think 160 is a.
Okay.
So
I see what you're saying. Let's just see what we get because I see what you mean. 160 is x bar, and x bar is the mean of the sample distribution, I think. So I think you might be right there. It just feels weird.
Because why else would they have those scores that way?
I think it's going to be 160 minus the 150.8, like she said. And then divided by 8.8.
So wait, we're doing 160 minus what?
Minus 150.8.
Oh yeah, Dex, that's what's up there. And then divided by the square root of 8. Is
5.
that what you got?
Okay, so what did you get, Sarah, for the z-score? I got 0.468.
I'm still. So the number that goes on top of the square root of n, do you remember which number that is?
Yeah, so the equation is x minus u over sigma, the standard deviation, times the square root of n.
Oh, okay.
And the square root of n in this case would be
5.
5.
So I got 0.468.
Yep, okay. I feel like this is a weird question, but you know what I mean, though, because
Well, just
the standard deviation is 8.8, so it's more than one standard deviation away. But I just feel like our z-score is really high.
I just can't think of any other way we would solve it, honestly.
Yeah. I mean, maybe that's not so bad. It's just...
Do you want to try something
No,
different?
I guess it's fine. I think that's okay. Let's just leave it. Okay, question 9 now. If we're all ready to move on.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round to your 4 decimal places.
Okay. We'll have a mean score that is greater.
So I got 0.3199.
Hang on.
So you just plug it into the normal probability app, right?
Yeah.
Remember what our number was. 468.
You got what, Sarah?
0.3199.
That's what I got
That's what
too.
I got.
Okay.
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 0.319.
Okay. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 will be drawn. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected? Left
You're
skewed, right skewed?
approximately normal.
I agree with Sarah.
Okay.
Because we have such a large sample.
Yeah. Okay. Well, that makes sense to me too. Okay. So what is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
What is and the distribution?
I have to remember what that is because I don't remember drawing from the
For
parent.
all possible samples of size 81 that could be drawn from the parent population.
I don't remember doing this problem.
I want to solve.
So I feel like this is different unless I'm forgetting something.
Don't we need to know the standard deviation of the sample?
What is, hang on, I'm just trying to gain more understanding of this question. What does the mean of the distribution of sample means of all possible samples of size? So where's our information? We already have the standard deviation, I think.
Is it still referring to the same thing?
Oh, I guess, sorry, it's not the standard deviation, it's the number.
No, I know, I mean, we have that already. Like, I think this is based off of the information above. So we have that. All samples drawn from the parent population. Weird. Okay.
Well, because we don't have the sample mean.
Well, that's what we're trying to find right now, I think. Let's see. The mean of GPA of BYU Idaho students is 3.5. And the standard deviation, well, I don't know, maybe we can just use the mean. Because if we're using all possible samples, shouldn't that approach the average mean, like the regular mean? Right?
Yeah.
Like, I remember reading somewhere that if you use, like, all of the sample means together should approach the regular mean. I
Yeah.
think. Something like that. So let's
But
just see what we would get with that.
if we say 3.5 minus 3.5, it will just be
You're right.
0.
0.7 is a small known the distribution is left skewed. If n equals 8.6.
Do you want to do 3.45 instead?
We could see that. 3 point.
Sounds weird.
Wouldn't it be the other equation where it's the standard deviation divided by the square root of the sample size?
That was how we found the sample mean before. I was looking at that, wasn't it?
Yeah, that's true.
Okay, let's try that.
Worded differently.
0.7 divided by square root. Okay. So then the standard, that's how you get the standard deviation. That's the same thing.
No.
Oh,
We just took the standard deviation and divided it by the square root of the sample size.
I mean,
So
that's
we
how
would
you
be
find
getting
the
the-
standard deviation of the sample. That's the equation for standard deviation, not for mean. Because if you looked at your answer, it's the same thing as the standard deviation, because we already found that.
Yeah.
Okay, I feel like we should have done this. I'm looking at my notes now. I don't know why. This is probably something simple.
It might just be the wording that's throwing us off. Because I'm looking and I haven't seen anything yet that looks quite the same.
Now I wish the TA was here. Ha ha ha.
I haven't gotten an email from her yet, so I don't know. I could try emailing her and saying, like, we invited you. Did you get this invitation?
Okay, I'm gonna look in the textbook reading that we did for this time, and you guys look around and see if anybody can find what the answer is for how to solve this problem.
Okay.
So I know at least that we don't use the normal probability applet for it.
Yeah.
No, it's so either.
So all this is supposed to be is a review of chapter 5 and 6. So I don't know why I'm not remembering this.
Sorry, I just sent an email.
Okay.
I feel so bad about. Okay. Fine.
Okay, previously we were talking about Z-score and the applet.
I think if we don't find anything in 5 minutes, we really should probably just move on. And then go.
Okay, we can always come back to it if we don't find something right now.
Yeah.
I would just give it a few more minutes. I mean, I don't even mind messaging you guys later if I figure it out. I doubt I'm going to be the one to figure it out because I'm probably the worst at math here, but.
Okay, Z-score.
I'm just looking in the textbook right now.
Trying to find the mean of the distribution of the sample means.
You could try emailing him too. When is the group quiz officially?
Maddie, you keep looking in the textbook. I'm looking in Google.
Okay. The parent population is normally distributed, so the sample mean is automatically normally distributed. For the mean of drive. You kind of mentioned the parent population, but it didn't really correlate with our problem.
We're not really dealing with the parent population much anyways, unless you can find an equation.
Yeah, well, that's just what I'm looking for, just because it mentioned that in the problem.
I don't think we have enough information.
Is that on?
Yeah, but that's not an option with the answer, so they have to have given us,
Well, the teacher may have accidentally not included that part.
We
I
could.
think the mean is just going to be the same.
I know, I'm starting to think that too, because I just found online that it says the mean of the sampling distribution of the mean is the mean of the population from which the scores were sampled.
I think it's just the 3.5.
Okay.
At least if we put that, we have something down.
Yeah.
So let's just try it.
We're just gonna rate 3.5 for that one.
Yeah.
Okay.
Because we're not really having any luck finding something different anyways. Okay, question 12.
Okay. Question 12. What is the standard deviation of the distribution of sample means for all possible samples of size 81 that could be drawn from the parent population?
I think that's just the 0.7.
Well, we'll find out. I think that maybe if we get all of these wrong, I don't know that we should take it again together.
Yeah.
I feel like if we get all these wrong, we need to just like leave it and go and do more homework on reviewing those sections because maybe we missed something, and then take them again ourselves.
Yeah.
13.
So we're just gonna go with 0.7 for 12.
Yeah.
Okay. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So this one you would plug into the probability applet after you're finished.
Yeah. Okay, so that's 3.3 minus 3.5 equals divided by 0.7.
Isn't it 81 minus?
No. 0.7 times the square root of 81. Okay, so I got negative 0.317.
That's what I got too.
I'm gonna plug that in. Maybe we can find it.
What'd you
0.317.
So I got that the area is 0.3756.
What were we trying to find? That it was less than that?
Yeah, so it would be on.
Yeah, so I got that too, Sarah. 0.3756.
Oh, and we round it to the 3 decimal places.
So it would be 0.376.
So 0, yeah, 0.3.
We just have 2 more problems left. What is the probability that the mean GPA for 81 randomly selected BYUI students will be greater than 3.3?
So that should be
That's
the
the
same.
same thing, it's just different on the applet.
Yeah, so you would just switch to the other side.
So 0.624.
No, it's the same number
Why?
because it's greater than 3.3.
Which this is 3.3. So it needs to be all this.
Yeah, don't we need to include the middle section?
Yes. Because it's greater than negative 0.317. That was z-score we found.
Annie, I think there was a problem where it was where they had it as the same. On number 15 on the homework, I feel like.
Well, because the first problem was what was less than 3.3.
Right,
Yeah.
I know that.
And we found the z-score for that. This next problem was greater than 3.3, but it's the same z-score.
I know, I just, for some reason,
Well, I don't know. I mean, you guys can try something different if you want. I just am going to do the whole thing. 0.6. Because technically, doesn't the whole thing need to equal 1? So what was less than it plus what was greater than it needs to equal 1. If we leave out the middle, it won't equal 1.
Yeah.
So it's 0.624.
You're probably right. Okay, I'm probably thinking of something different. Okay.
I don't know. 15. This is a long one. Take a breath, Maddie.
The United States Coast Guard assumed the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident.
Well, that's not good.
The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is an extreme or more extreme, either above or below the mean, than was observed in the sample. Round your answer to 3 decimal places. Example, if the answer is 0.896, then you would enter 0.898 in the answer box. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction. Wow.
Okay. I see what she's saying, or he's saying, or whoever wrote this. So we're just going to use the sample mean that they gave us, I think. And then just do like what Annie was trying to do with this last problem. And not highlight the middle, but I need to reread it really fast.
But it should be the left and right section.
Yes, yes. The United States is 185. So that
What would the equation be for this?
value was. We still need to find the z-scores. The previous value was lower, but was reasonable. Standard deviation, passengers, blah blah blah. The sample mean was 177.6. Okay, 177.6 minus.
So this, yeah, the z-score isn't it negative 0.04?
I'm just getting there. I was rereading everything.
So what would x be in there? So I'm trying to.
The sample mean they gave us.
So the 177.6.
Okay. And then you would minus it from.
The 185.
Delete.
Oh, because that's actual. Okay, yeah.
Okay, I got negative 0.04. What did you say you got, Sarah?
That's what I got too.
Okay, that's good.
So it's 0.968 is what I got.
I don't know. This just feels weird now. It feels like that shouldn't be the answer.
I'm sorry. Can someone just remind me what equation we're using for this one?
This is the regular equation that we use for standard deviation on all the other problems, Maddie.
Okay.
The standard deviation passenger. The sample mean was determined to be 176.6. Find the probability that passengers will have a weight that is extreme or much the mean than was observed in this sample. I mean, I feel like what we did fulfills the requirement. I feel like that's such a high percentage.
That's what I think, but I think we should just go.
Yeah.
Okay.
Well, I think it's basically asking, well, the question is asking what numbers are not going to be the mean, like what percentage. So they'll still be, they can still be close by,
Right.
but it couldn't be 100% because some of the numbers are going to fit the mean.
Yeah, I just feel like our z-score is just really like low. But I mean, I feel like that's how the problem should be done.
I think we should just go with it.
Do you guys think we should just submit them and see how bad we did?
Okay.
So everyone agrees on the answer for 15. We'll move on.
Yeah.
Yeah, I mean, I still feel weird about it, but it's possible it's just the numbers that they use.
Okay, go to submit quiz. Okay, 4.
Yeah, we did miss those ones.
Yeah, I only got 11 out of 17.
That's what I got.
I agree. So we'll have to take this again, but let's see exactly which ones we messed up on. So we messed up on what was the first one? Question 8, which was, I felt like we had done that one correctly, so maybe we just missed a piece of information, because this wasn't the one that we thought that we were going to mess up on.
Yeah.
Number 8.
I got 10 out of 17, so I must have accidentally inputted something wrong.
Yeah. Okay, and so then we got number 9 because that was based off of number 8. Maybe we just calculated the mean wrong, people. It's probably something simple like that. Maybe we just should have used a more complex equation or something. Or typed in like the wrong population mean or whatever we were doing. Okay, so number 9.
I'll probably go over the online textbook again and see if there's anything in there.
Yeah, and the ones where we weren't sure about that, the answers were wrong for those. So it was a separate equation that we had to do. Okay, 12, 13, 14.
Okay, so I guess we'll just...
Yeah, and the last one wasn't the right answer either. So we definitely are missing something. I feel like it's probably simple, and I bet I have it in my notes because I know we did a problem just like the last one on the videos. I think we're just getting confused at the wording and stuff. So let's just go do them on our own later and see if we can find help in the videos and things for these specific problems.
And I have no problem, like, putting in a group thing on Gmail and just writing down.
Okay.
If we figure something out, we can let each other know and still help each other out, you know.
Okay. That's fine. We can just send an email or whatever.
Yeah. Okay.
Well, thank you.
Bye, everyone. Have a good day.
See you later.